This is the third part of lecture 3, and in this part we'll learn about continuous sterilization process. The overall plan of continuous sterilization system is same as batch sterilization systems, and like the batch sterilization system, in continuous sterilization medium is heated to reach to the sterilization temperature, holding this temperature to particular period of time and then cooling the media to reach to the temperature of the fermentation process. That means, like the batch fermentation, here the three steps will be also present here: the heating step, the holding step, and the cooling step. Okay. However, unlike the batch fermentation process and batch sterilization process, in continuous process high temperature is used. Like in batch, the maximum temperature is used can be used is 121 degrees Celsius, but it's in continuous process much higher temperature can be used, for example 140 degrees Celsius. So as higher temperature is used, thus we can reduce the holding time, and thus we can prevent the damage of the nutrition. That means we can actually keep the quality of nutrition, okay, by preventing them from heat damaged. Okay, and this is one of the significant advantage of the continuous process. That is, a much higher temperature may be utilized, reducing the holding time and reducing the degree of nutrient degradation. Okay, and like the just like the batch sterilization system, the required del may be achieved by combining the del factor of heating, holding, and cooling step. Okay, and if we graphically see the continuous sterilization process, it looks like this. For example, in x-axis, if you put time t, and y-axis uh, temperature, you can see that, I mean, say you will use 140 degrees Celsius for your sterilization. So from the graph you can see that you actually have to keep the temperature for very short time. Okay, the holding temperature will be very short. So as the media will be exposed to this high temperature for very short time, so thus less amount of nutrients will be get degraded. Okay. Okay, now so now how a continuous sterilization process is done. The temperature of the medium is elevated in a continuous heat exposure and is then maintained in an insulated serpentine holding coil for the holding period, and the length of the holding period is dictated by the length of the coil and the flow rate of the media. Then the hot media is cooled to the fermentation temperature using two sequential heat exchangers. Okay, so the first one is the first utilizing the incoming media as the cooling source, thus conserving heat by heating up the incoming media, and second using cooling water. That means, okay, whatever the process is, it may be batch or continuous, we have to heat first, increase the temperature of the media, then we have to decrease them, that means we have to cool them, right? So in case of continuous sterilization process, temperature I mean the increase of temperature of the media is done by using a by continuously exposing the media into a heat source. Okay, by this we can heat the media, but after the holding period is done, then we need to cool it up. So this cooling down is done by using heat exchangers. So in this case, basically two different heat exchangers are used. Okay, that's why they are called two sequential heat exchangers. In one heat exchangers, the incoming unsterile media is used. Okay, so the incoming unsterile media, they are cold, right? So if you can use the incoming unsterile media as a coolant, then this unsterile media, they will absorb some of the heat of the sterile media. Okay, so thus they themselves will get some energy from the already heated media, and at the same time it will help the heated media to cool down, right? So it will actually also serve two purpose. One, as the incoming cold media, they are getting the preheat, they are getting preheated by the already heated media, so it will be a cost effective way, right? It will be a cost efficient method. Okay, okay, so this was one heat exchanger. In another heat exchanger, cold water is used to cool down the heated sterile media. Okay, now based on the types of heat exchanger, continuous sterilizer, they can be classified into two types. One, indirect heat exchanger, and two, direct heat exchanger. Okay, so first I'll talk about the indirect heat exchangers. Okay, so indirect heat exchangers, there are also two types. One is in the spiral heat exchanger and another is sheet type heat exchanger. First I'll talk about the spiral heat exchangers. Okay, so the most suitable indirect heat exchangers are of the double spiral type, which consist of two sheets of high grade stainless steel which have been carved around a central axis to form a double spiral. Okay, and to achieve sterilization, temperatures steam is hot steam is passed through one spiral and the medium through the other in counter current streams. Okay, and in spiral heat exchangers are also used to cool the medium after passing through the holding coil. Okay, and for doing so, in doing so, incoming unsterile media is used as the cooling agent in the first cooler, so that the incoming media is partially heated before it reaches the sterilizer and thus heat is conserved, and in the second cooler cold water is used. Okay, so if you see this cartoon figure of a indirect spiral heat exchanger, I think it will be more easy to understand. So if you see the arrow, direction of the arrow, okay, so these are a spiral heat exchanger, and this is the inside of the spiral heat exchanger. Okay, so you have to inject or flow the unsterile media in one direction, and you have to flow the heat, as you are using heat here, so you have to flow the steam in opposite direction. So as you can see here, okay, media, they are flowing in this direction and steam in opposite direction. So if you see, look at this photo, steam, you are injecting steam in this direction, okay, and the unsterile media this direction. So the unsterile media, they'll enter here and they will follow spirally, and finally they will get removed from this way. Okay, and during their flow they will get the heat from the steam. Okay, and thus will be sterilized. Okay, these are some more photos of the continuous spiral heat exchangers. So if you are interested, you can just look more carefully. Anyway, the spiral heat exchanger, it has some advantages. So what are the advantages? Two streams of medium and cooling liquid or medium and steam are separated by continuous stainless steel barrier. That means in the this kind of spiral heat exchanger, I mean the two stream, the stream of steam and the stream of media, they are separated by stainless steel. So that's why cross contamination is highly unlikely. There is very few chance of cross contamination. Okay, and also the spiral route traversed by the medium allows sufficient clearance to be incorporated for the system to cope with suspended solids. Okay, that means, I mean, the media may contain some suspended solids and they can get stuck in the inside the sterilizer, but as the media, they are continuously flowing. Okay, and the flowing is very smooth through the spiral tube. Okay, so actually it gives sufficient clearance that the suspended solids, they cannot get settled down inside the sterilizers. Okay, rather they are continuously in move and get easily cleared. Okay, that means they actually get very few chance to get settled down in the sterilizer and cause problem. Okay, now we are done with the indirect spiral heat exchangers. Now I'll talk about the indirect plate heat exchangers. Okay, so the indirect plate heat exchangers, they consist of alternating plates through which the counter current streams are circulated. Okay, and the plates are separated by gaskets. So it's actually a problem because as the plates are separated by gasket is and this most of the time these gaskets are made of rubber. Okay, so if these gaskets fail, cross contamination will occur. Okay, however, in either case, please keep one thing in your mind that in both a spiral heat exchanger and plate heat exchanger, the flow of stream and unsterile media will be counter current. That means in opposite direction. Okay. Anyway, uh, this was anyway. I mean, as I just said, that a failure of the gasket can cause contamination between the two streams. That means between the uh, steam and the media. Okay, it actually has a further problem. I mean, this indirect plate heat exchangers, it has some additional disadvantages. For example, the clearance between the plates are not as efficient like the spiral heat exchanger. Okay, so that's why suspended solids, they can get easily settled down inside the inside the sterilizer and may block the exchanger. Okay, so that's why indirect plate heat exchanger are not suitable for suspended solids. So if you want to sterile suspended solids, you have to go for the spiral heat exchanger. Okay, and but if your media do not contain any suspended solids, you can just use indirect plate heat exchanger. Okay, so this cartoon photo, this is a real photo. This cartoon photo is it shows a design of or inside of a plate heat exchanger. Okay, so many plates are used here, and again, like the continuous heat sterilizer, the flow direction of the media and the steam will be in counter current. Okay, in opposite direction. Okay, okay, and this actually show the you can say this is the flow chart of plate heat exchanger. I mean the flow chart of the events that occur in the uh, uh, plate heat exchanger. Okay, so what happened inside the plate heat exchanger? So these are different plate. Okay, so you can inject the raw medium from here this direction. Okay, so ignore this sheet first. So the raw medium, they are traveling through. Okay, and then they're entering this plate, and you're injecting the steam in this plate, so they will get sterile by the heat from the steam, and then you have to hold them for some time. Actually, you will do this holding, and this holding period will be achieved in during this in the place. Okay, so every events will occur here. Okay, in the place. Okay, so after they get sterile from the steam by the heat of the steam, we have to hold it actually, and will achieve this holding by designing the plate exchanger in a way that for this desired time the raw media will be exposed to the desired temperature. Okay, then when the sterilization is done, now the media, they are leaving, and upon leaving we can use this. I mean this media, this sterile media is still hot, so we can use this hot media to preheat the raw media. the raw media is cold. Okay, so when it's travel through here, if we can expose this raw material to the already sterile media, so they can get some heat from this sterile media, and it will serve two purpose. One, the raw medium, they will get preheated, and again the other purpose will be served will be the sterile media, they can get cooled down here. Okay, and finally the sterile media, they are cooled by using cooling water. Okay. Okay, so that was about the indirect plate heat exchanger. I mean, we're actually done with the uh, indirect continuous sterilizer. I mean, we have already talked about the indirect spiral heat exchanger and also indirect plate heat exchanger. So now we'll talk about continuous steam injector. Okay, so continuous steam injector is the way of sterilizing media by direct way. Okay, so the spiral plate or the spiral or the plate heat exchanger, these were continuous heat sterilizer but indirect method. And continuous heat exchanger, continuous steam injector is also a continuous process, but in this case the media will get sterilized in a direct method. So why we are calling this why it is called a direct method of direct methods of continuous sterilization? Because in this case steam is continuously directly injected into the unsterile media. Okay, there, I mean, we directly inject the steam into the unsterile media, which sterile the media. Okay, and this method has some advantages and disadvantages. The advantages are very short heating up times. It may be useful for media containing suspended solids, because if we want to sterile the media with suspended solids in a continuous way, so they get I mean by using continuous plate exchanger or a spiral exchanger, in either case there is a chance that the suspended solids, they may deposit there. Okay, and block the sterilizer. But if we use continuous steam injector, there is no chance of such event. Okay, then capital cost is low, cleaning and maintenance is easy, and high steam utilization efficiency. I mean, we can use steam very efficiently. I mean, steam will not lose any heat to the environment. Rather, all the heat absorbed by the steam will be utilized for sterilization. Now, the disadvantage of continuous steam injector. Okay, foaming may occur during heating, and direct contact of media with the steam requires that allowance be made for condensed dilution and requires clean steam free from anti-corrosion additives. I mean, the steam definitely they will be sterile, but also the steam should be clean. They should not contain any unwanted particles in it. Okay, and also, like, we'll directly inject the steam into the media, so that means the media will be get diluted. So if we want to I mean use continuous steam injector to sterile our media, we have to calculate that what will be the initial concentration of our unsterile media and how much steam will inject there. So thus the final the final concentration of the media will be on the expected range. Okay, so this kind of things need to be calculated before we use the continuous steam injector. And like the all the other sterilization media, cooling is also, I mean, like all the other sterilization process, cooling is also required in this case. Like if we also I mean sterile our media by using a continuous steam injector, we need to cool the media after the sterilization is done. And for doing so, in some cases the injection system is combined with flash cooling. Okay, where the sterilized media is cooled by passing it through an expansion valve into a vacuum chamber. Cooling then occurs virtually instantly. So we already know is we already know that in case of continuous sterilizer, two heat exchangers are used to cool the media. Okay, however, in this kind of design we can add a additional step which can cause a flash cooling of the media. Okay, so let's see how it is done. So this is a flow diagram of a typical continuous injector flash cooler sterilizer. Okay, so these are those two heat exchanger. So okay, so how we are doing the so these two are the heat exchangers. So we are injecting the unsterile media from here. Okay, in this direction they are passing through the preheat heat exchanger where sterile media is used as a preheater. So the unsterile media they are passing through heat, getting preheated. Then we are directly injecting the steam into it and we are holding them. Then we are just expanding them into a larger volume. Okay, so this will cause the expansion of the liquid media, and this heated liquid media then will rapidly release the heat. That means they will rapidly get cooled. Okay, then I mean they will rapidly lose some heat, doesn't mean they will be completely cold. So after this step, then this media they're still kind of heated, so we'll pass them through the first heat exchanger, then the second heat exchanger, and the second heat exchanger cold water are used to do the cooling. Okay, so that was all about the continuous heat sterilizers. Okay, and in the next part we'll talk about some advantages of continuous sterilizer over batch sterilizer. Okay, thank you for your patience.